In the last episode, Kate and Christopher discovered two patterns that allowed them to find more distance and time values that made the red car travel the same speed as the blue car when the blue car was traveling 10 miles in 4 minutes. In this episode, Kate and Christopher find some patterns that do not work.
Can you write down, Christopher, a pair of values that you think would be same speed values? Another pair.
Mm-hmm. 5, 8. I think that because we are dividing this number by 2. Okay, so we're dividing this number by 2. So in turn, to make it even, we multiply this number by 2.
So my question is, would the 5, 8 go the same speed as the 10, 4?
I think so.
Want to check it out? Let's see.
5, 5, and 8.
So before you go, can you tell me your reason, your pattern for why that's going to work?
Well, so for 10, we just do divided by 2. So for 8, we do times 2.
I don't think it's going to work.
I'm not completely sure myself.
Well, Christopher, why don't you hear Kate's idea about that?
Yeah.
I don't think it's going to work because I think 5 and 2 would work, but not 5 and 8 because
That would make more sense. Yeah.
so
But
What would make more sense about it?
it would make more sense because all of the others were working in that strategy. So, yeah.
Do you want to still check out what would happen here? Well, let me check it out. Let's see what happens.
I'm curious to see. Yeah.
So what's happening there? Why didn't that work?
The thing is, the Ferrari goes 5 miles and goes 8 minutes. Longer than this, shorter than that.
It's shorter than what? Tell me more about that.
So it's short. It has shorter miles to go, but it takes longer time.
The Ferrari.
Yeah.
Christopher had an idea that was worth checking out. First, he divided the number of miles that the blue car traveled by 2 to get 5 miles. Then he multiplied the number of minutes by 2 in order to keep it even. It is like he is saying that multiplying by 2 balances the previous action of dividing by 2. Then they made an important discovery. This balancing pattern does not work. The two cars did not travel at the same speed. Next, Kate and Christopher examined an idea for a pattern that another student suggested. That student said, if the blue car travels 10 miles in 4 minutes, we already know that if the red car travels 20 miles in 8 minutes, it will go the same speed as the blue car. If you add 2 to the number of miles and the number of minutes, you get a journey of 22 miles in 10 minutes. Kate and Christopher make a prediction whether or not the two cars will be going the same speed if the red car travels 22 miles in 10 minutes and the blue car travels 10 miles in 4 minutes.
Christopher, can you write down 10, 4 and 20 and 8? So I was working with some students before, and they told me another same speed value would be 22 and 10. Did you add 2?
That would work.
That would work. So let's write it down.
Okay, so 10, 4.
And then 22 and
10, 4.
And 22 and 10. So you want to check this out? Do you think it's going to work? Yes or no?
Kate, do you think it will work? Do you?
but yeah, I do.
I didn't have to change the 10 variable at all. I just had to change 25. I had to change 25 to 22. That's all. Since that worked, I don't exactly think that 22 and 10 will work.
Earlier, Kate and Christopher found many values of distances and time that resulted in the red car traveling at the same speed as the blue car. Christopher remembered that 25 miles in 10 minutes was one of those values that worked. He argued that if 25 miles worked with 10 minutes to make the cars travel at the same speed, then no other amount of distance can be paired with the time of 10 minutes to result in the red car traveling at the same speed as the blue car. But Kate still thinks that 22 miles in 10 minutes might work, because the same value of 2 was added to both the distance and time. So they run the race to check.
Why do you think it's going to work, Kate?
Okay, adding 2 to something that's already equivalent to 10 and 4. I'm not 100% sure, but I'm pretty sure.
Okay. What do you think, Christopher?
I am 100% sure it will not work.
Go. Wait, go. Look, stop. See, they're not the same distance. They're not.
Who's going faster?
The learning game is just like tiny bit.
Kate and Christopher made some important discoveries. In episode 1 of this lesson, they noticed that multiplying both distance and time values by the same number worked. The two cars traveled at the same speed. In this episode, they figured out that adding the same amount to both distance and time values does not work. One car traveled faster than the other. In the next episode, they figure out why multiplication works.